Makerbot announced the release of their Method 3D printer, and it got a lot of people talking. Mostly talking smack, though. Hey guys, it's Joe, and honestly, this wasn't the video I wanted to release today. I wanted to announce the Filament of the Month Club is starting right now. It's not quite ready for prime time, and this isn't an example of the filament that you'll get. I'm partnering with Alien 3D to get you cool filaments, and it's not just going to be red PLA. We're going to be doing like the buzzed PLA or this cool little granite PLA that I haven't shown you yet, but the prints of it are super cooler. Maybe if you guys want to, if you guys are interested, I might get you guys some Poly Smooth. It will be always something cool and interesting, the sort of filament that you looked at and you said, I'd like to try that out, but I don't want to get a whole roll. No problem. I will send you enough to print a whole bunch of little projects so that you can see how much it is. It's a generous size spool. Alien 3D, if you know them, you know that they do quality stuff. If you guys would like to join the Filament of the Month Club, it is available right now at 3dpprofessor.com/shop. You can sign up for that, get a sample roll of filament, and because I'm not done getting it ready, special discount for a little while, but as soon as I get those pictures up and everything's ready to go, that will go to the regular price. So if you're watching now and getting in early, you can do that. But that's not what we're here to talk about today. We are talking about Makerbot and the Makerbot Method. No, the Makerbot Method is not some idea for getting things done. The Makerbot Method is their new 3D printer. And a lot of people, especially people in the hobbyist market, are not excited by this announcement. For instance, the famous Tom Salander says, "Can someone explain to me using simple language what a performance 3D printer is?" Because yes, their release was full of marketing speak. Boilerpoint points out that their example 3D print is encased in support material on top. Why would you do that unless you're just trying to charge people extra PVA? Well, 3D Tanny says it's proof that Makerbot doesn't know how to 3D print, and come on, we know that's not true. But other people took offense with that sample print because it really was very clearly a rendering, not an actual 3D print. Although there were 3D prints on their website, and Jeremy the printer pointed out how if you zoomed in close, there's a lot of nasty little zits on their example print. The Link 3D says, "So this is the new Makerbot 3D printer, the Makerbot Method?" I was expecting something a bit more innovative, to be honest. And Joe Mike says, "What the heck is this flaming pile of crap?" Akish One, great supporter of the channel, and hey, buddy, your low poly dino prints were amazing. He says, "This is what companies are going to convince schools to buy to, quote, get into 3D printing." And you know, that is a legitimate concern that this name Makerbot means something to people outside of our hobby. It means a quality printer, and if Makerbot is not going to deliver on that, this could be a real problem. So let's dive into Makerbot's copy and see what exactly we're looking at right now. The 3D Printing Professor is supported by you. Viewers like you can support videos like this directly on PayPal and Patreon and make the projects and builds you see possible. To support, find the links wherever links are found. Now, of course, we are not looking at the 3D printer. That is to say, I don't have one. All we've got is this website. The Method, the first performance 3D printer. Does that mean that it performs? Because I've got 3D printers that perform. Bridging the gap between industrial and desktop 3D printing, starting at $65,000. Now, that is not cheap, but it's not super expensive either. It sits in this kind of area where the Raise N2 is and the Fusion 3 sits. There are a whole group of 3D printers, but this one comes from Makerbot, or does it come from Stratasys? See, I'm not really sure. And see, I'm gonna skip all of this for now. We'll come back to that later, because down here, we'll skip this for a second. Down here, we'll skip this for a second. Here we go. There we go. This, in my opinion, is what Makerbot should have led with. Check this out. Uncompromised performance from the inside out. Sure, okay. 21 onboard sensors. Yes, I 100% am behind 21 onboard sensors. I've long said 3D printers need more sensors. What are these? Where's the list of what these sensors are? I don't know. I don't see any list of what these sensors are, but 21 sensors is good. They do have humidity and possibly temperature sensors in where the filament is stored, because they want to make sure your filament is in constant optimal condition. And that's actually a big deal. I've never seen anybody do that, and I'm 100% down with that. That is fantastic. Now, where the rest of the sensors are, I don't know, but more sensors, the better. I'm happy with that. Now, I know that this is marketing talk, and I'm pretty sure that they're faking it on some of these sensors, but you know, that's a good thing to say, that we are monitoring your print in every way possible to make sure it'll be good. There aren't enough sensors on the cheap Chinese printers, so I'm down with this. Wi-Fi connectivity, also down with. Oh my goodness, you guys will see the printer that I will be reviewing next week. I gush about Wi-Fi connectivity, and I've had the chance to use Wi-Fi connectivity on the Rays 2 in the makerspace. I love never having to do the SD card shuffle ever again. So Wi-Fi connectivity, big plus. Remote monitoring and printing, which is good. Makerbot machines have been doing this for a while. Their 5th gen machines had a little camera on them. I wonder if they're counting a camera as a sensor. That's okay, I'll allow it. And you could look in on your print over the network remotely while it's going. You don't have to be sitting next to your printer. That's a good thing. 100% down with. Well done. 25 compatible CAD file types. I want to know what those 25 compatible CAD file types are, because why isn't Cura and Simplify 3D and Slick 3er and all the rest of them reading all of these same CAD file types? Kudos to them. Now that's a slicer thing, but you know, it's a whole package. The slicer's a part of the whole package, so that you can read 25 I could see that being a big plus to somebody in an industrial setting who says, yeah, I want to know that I can export straight from Fusion 360 or SolidWorks or AutoCAD or whatever. I want to be able to not have to use, you know, I don't want to have to export an STL or an OBJ or even an X3G, although I'd like to have that option if I could. I want to have my file types accepted natively, so that's good. 5-inch color capacitive touchscreen. You know what? I'm actually super down with touchscreen controls. I love them, and so big plus. And a bunch of hours of reliability testing with a little asterisk there, but we're not gonna worry about that. That's, you know, okay, fine. They've tested it for reliability. That's good. Let's scroll down here. We'll explore the tech specs in just a second. Let's come down here. Fastest CAD to part workflow. All you got to do is CAD it, then print it, then rinse it. Then you got your part. Now, I'm not quite sure what this means, fastest CAD to part workflow. Does this mean that you can export directly from your CAD, like they have built plugins into common CAD programs so that you don't have to go to the slicer? Have they set up their slicer so that it automatically orients and puts in supports and decides how it prints? Because I would be completely down with that if they just automated that entire process. They're not saying that you can export directly from CAD, but they're kind of implying it. If it ends up being the case that you can do that, that is a very good thing, and I can see that being a benefit to a lot of people, but they're not saying that. They're just saying it's fastest CAD to part workflow, which is good, and I'm down. I just don't know what that means. Print up to 2x faster than desktop 3D printers. It's funny how 2 little words, 4 letters, can make this entire statement just about meaningless. Do you know what those 4 letters are? Up to. Up to 2x faster means that it might not be 2x faster, but it would still be true to say that it prints up to 2x faster So that's just saying, yes, I can go faster than you. I don't necessarily, I'm not going to do it maybe, but I could. It could be 2x slower, and this statement would still be true. It's marketing speak right there. They think they've got a system that goes faster than normal desktop 3D printers, and I wonder what they think is a normal, traditional desktop 3D printer. Like, are they comparing it to the 5th gen Makerbots? Because those were not fast. They weren't slow, but they weren't. I've seen and used faster 3D printers. There are faster 3D printers out here. We'll come back to this later. Right now, I want to explore some tech specs. We'll come back here, but let's take a look at the tech specs. Let's see. 2 print heads, fantastic, love it. Print range, that's good. Build speed, build volume. Here we go. How much build volume are we getting for the money? And this is where the conversation starts going downhill fast. 7.5 inch cubed build volume, maximum build volume, a 190 millimeter build volume. That's not CR10 size. That's not even Ultimaker 2 size. It's bigger than a Mini. It's bigger than a lot of things, and it's almost as big as an Ultimaker, but it's not even as big as an Ultimaker. And maximum flow rate 50 millimeters per second cubed, and print head travel speed up to 500 millimeters per second. I will admit that's fast, but this build volume for $6,500, you can't even build as big as an Ultimaker. Whew, that's not good. That is not good. I don't care how long you've tested it. If I can't, I've used 3D printers in the maker space, and I've seen people come in and push the size of the Ultimaker regularly. If you're telling me the engineers can't even get to that size, that's not good. All right, let's go on. Let's take a look. Let's see, flexible steel build plate. And what's interesting is this build plate is not heated, because the entire chamber is heated with a circulated heating chamber, which is honestly super cool. Them heating up the entire build chamber is something that they're only able to do because Stratasys holds the patent on heating up the build chamber, which is ludicrous. But nevertheless, nobody else can sell a 3D printer that keeps the entire build chamber at a specific ambient temperature. I'm scrolling down to see if there's a picture of it, but there's no picture here. So never mind that. It's perfect. It's fantastic. They're also really stressing that they have new, they're not smart extruders, but they sure look like them with a really long Cyrano de Bergerac end on this. And I'm willing to give them the benefit of the doubt. I'm hoping that they learn from their experience with the smart extruder and they're not going to turn this into a $350 consumable, but I just don't know. Smart spools with RFID sensors. Oh, that's not good. That's kind of bad, actually, because it means that you can't use spools of filament from other places. Their filaments are chipped, and if you try to buy it from somebody else, if you try to buy it from anybody other than Makerbot, now that does have the advantage, theoretically, that it means that they're controlling their filament. They know exactly the filament diameter, and so they can adjust for that to make their prints more accurate. But there was something I skipped up front, or up earlier. Let's go back and take a look at that. The very first thing after their weird performance printer marketing speak is this right here on the left, where the English trained eye goes to first to read. It says dimensional accuracy of plus or minus 0.2 millimeters. What? Who brags about a dimensional accuracy that is so bad it's half a nozzle diameter bigger or smaller than your print is supposed to be? That is printing on the lines bad. By that I mean early slicers had the mistake of when they decide the shape of the line, they would then draw on the edge of that line. And that had a problem because you were drawing with a 0.4 millimeter extrusion. So everything you printed was 0.2 millimeters in each direction off. Really bad. And it meant that prints didn't mesh together unless you designed them to be smaller. I know for a fact that Stratasys caught up because they made a big deal. I saw a presentation where they were like, yes, we have finally decided to color inside the lines like we should have been doing for years. Stratasys knows this. Makerbot knows this. So I know that this can't be the problem. But why? Why is this brand new 3D printer saying that they have a dimensional accuracy of plus or minus 0.2 millimeters? If you were to print Legos with this dimensional accuracy, they would either not be able to fit together because they're too wide, or they would fit together and then fall apart without actually sticking because they're too small. 0.2 is huge. This is really, really bad. Now, I should point out that it's plus or minus 0.2 or plus or minus 0.002 per millimeter of travel, whichever is greater. So it's does that mean that it actually gets worse the longer a line that you're doing? I think that the problem is they pushed their speed so fast that they couldn't slow down in time to go around corners, and it's ruining their dimensional accuracy. Guys, toss out this so that you can lower this down to no more than this. If I were an engineering company and I were looking for a 3D printer, and that's who this is marketed for, engineering companies, and I saw this, hard pass. I'm going to have to move on past this, but just keep in mind that this is in the back of my mind the whole time. Now, they are making a big deal about the cost benefit of using this 3D printer. And it's true. This 3D printer is a lot cheaper than using a entry-level industrial 3D printer. And I can tell you what they're comparing that to is their Fortis 3D printers and their Uprint 3D printers. Now, I've had the chance to use a Uprint and Stratasys' high-end 3D printers in real life. I've had the chance to see them work, and they are fantastic machines, but they are super expensive. They would charge $300 for a kilogram of plastic, and it's actually 2 kilograms of plastic because they send you the support material with it. But that's a lot. That's a lot for the consumables, and so they're essentially saying this is cheaper than that. Now, this brings up an interesting question. This is where the perspective on this is very important. See, a lot of people, I think, were upset by this announcement because when they heard that Makerbot was announcing something big, they were like, ooh, this might be a return to the Makerbot that we knew. Maybe it'll even be, dare we say it, open source again. And then this gets released, and it's not only more expensive and not marketed towards the hobbyist consumer market, it is in fact more expensive and marketed away. It feels like Makerbot is taking a step away from us again, and that hurts. But what if that's not the case? What if this is Stratasys? Stratasys, who has been making the Fortis lines and the Uprint lines and all these other 3D printers, taking a step towards the consumer market, towards the hobbyist market, bringing their prices down to a more reasonable level and not charging a ridiculous amount for their 3D printers. And they're just using the Makerbot name. They're essentially carrying Makerbot around like a weekend at Bernie's because Makerbot is actually dead and it's really Stratasys. That was morbid. If viewed from the perspective of Stratasys taking a step towards us and not Makerbot taking a step away, this could be a very good thing. In fact, this could even be in line with the vision of Makerbot. To remind you, when Makerbot started, and a lot of us remember these Makerbot days, and if you want to hear the story, I've got a video about it. But when Makerbot started, Makerbot's goal was to make 3D printing available to the world. They wanted to make a 3D printer in every home. And some people thought that was ridiculous, but look at us now. Not 5 years, maybe 10 years later. And 3D printers are now more accessible than ever. There are more 3D printers in the world, and chances are there's one near you. Makerbot may not have been able to see their vision through to the end, but what they started, and yes, it also started with the RepRap project, and we shouldn't discount their part of that. But Makerbot was really the first commercial entity to make money and show that you could make money and a name in 3D printing. And in doing so, China came in and took over. And yeah, we might see that as a bad thing, but the truth is that's really what propelled 3D printing to where it is now. Makerbot succeeded. Makerbot won. And while Makerbot itself is now lobotomized and gutted and dead and being paraded around by Stratasys, it's still in its way, because keep in mind, Stratasys was the first FFF 3D printer. They hold the patents because they invented the technology, and here's Makerbot, here's the Makerbot name, bringing them closer to us. In that view, this is a very good thing. This is absolutely the Makerbot dream coming real. Now, it's maybe not the way that we would have chosen, but it is a very good thing. Now, in the end, do I recommend the Makerbot method? I still would not say no to trying one out. I would love to see how it does. And I'll print a whole bunch of Legos and see if they knock together and see how bad that dimensional accuracy is. But what do you think? Is there just no hope for Makerbot, and are you just so jaded by this whole thing that you don't even want to hear it? Or do you kind of see that maybe there's some good that can come out of this? I'd love to hear your ideas in the comments below. And as always, thank you very much for listening to me ramble and watching to this point. Big thanks to my direct and Patreon backers. Got the new tiles up there, so we're going to be getting some more of those up there soon. And also remember the Filament of the Month Club. Obviously not the red, but Filament of the Month Club. You can sign up for that at 3dpprofessor.com/shop if you are interested. And as always, I want to remind you, safety first. See you next time. Why would you lead with that in your copy? Just hide that, bury that just a little bit. I mean, kudos to them for being honest.